All right, so this is an attempt to be able to help explain the homework. We'll see how well this goes. This is going to be an additional video that you don't have to watch, but it will be available to you if you need help, and you can skip through it if you want to get to a certain problem. But here is your homework A for 4.2 explained. I'm just going to do the homework with you and see if that is helpful. Please let me know if it is not helpful, or if it is helpful. Tell me either way. Okay. Given that y varies directly with x and y equals this when x equals that, find y when x equals 5, x when y equals 672. So all of this helps me realize that I'm going to need to first make an equation to find out what this relation is. I know it says varies directly. So first, maybe to the side over here, I'm going to say y equals kx. Y equals kx. And as always, we need to solve for k first. So I'm going to plug in 462 for y equals k times x, which is 11. I need to solve for k. Grab my calculator. 462 divided by 11. So I get that k equals 42. So that my final equation is going to be y equals 42 times x. Y equals 42 times x. So then I can go ahead and answer A. I'm going to solve for y when x equals 5. I'm going to plug in 5 for x. So 42 times 5 is 210. Y equals 210. All right, moving on to B. I'm going to solve for x when y is 672. So I plug in 672 in for y over here. 672 equals 42 times x. I'm going to divide both sides by 42, and I get that x equals 16. Done. Hopefully pretty easy. If not, I would definitely recommend going back into those prior knowledge pieces that I have provided for you on the website and get some additional practice in. All right, problem number 2. Y varies directly, so y equals kx. Y equals kx. We know, y varies directly with the square of x, which means I'm going to make x squared. That's all I have to do. Y equals 10 when x equals 5. So I'm going to do 10 equals k times 5 squared. That's going to be 10 equals 25k. Divide both sides by 25. I know that that's going to come out to a nice terminating decimal, and that terminating decimal is 0.4 equals k. So my final equation, y equals 0.4 times x squared. Don't forget that squared piece. So this is kind of a side thought over here. In order to solve for this piece, I need to solve for y when x equals 20. I'm going to do 20 squared right there. I'm just going to go ahead and plug this all into my calculator. 20 squared times 0.4 is 160. Okay. Y equals 160. Now I'm going to go ahead and solve for x when y is 40. So I'm going to plug in 40 for y equals 0.4x squared. Divide both sides by 0.4. And that's 100 equals x squared. Taking the square root of both sides, I get plus or minus 10 equals x. Problem number 3. The height of this image, height is n, Or no, that's an image. Sorry. The height of an image produced by a projector varies directly with the distance from the screen. Okay, so varies directly. Y equals kx. It's the height of an image. So y, I'm going to maybe say that's h for height. Varies directly with the distance. So remember that this varies directly with that. So x equals the distance from the screen. So now I've got my variables labeled. The image is 1.5 meters tall. So at 1.5, when the projector is 2 meters from the screen. So I've got already an example for x and y that I can plug in order to solve for my great unknown k. It says find a direct variation model of the image S given by distance from the screen. Oh, so it tells us that height should not be h, height should be S. YS? I don't know. That's weird. Oh well. Okay, so solving for this, first I'm going to plug in my variables. S equals K times D. I'm going to go ahead and plug in the numbers that I do have. 1.5 equals K times 2. So I'm going to divide both sides by 2. That is 0.75 equals K. You can plug that into your calculator, no big deal. So I get that S equals 0.75 times D. Done. Hence, predict the size of the image for a projector. So size is unknown. 7 meters from the wall means that D is 7. So I go ahead and plug D or 7 in for D. So S equals 0.75 times 7. 0.75 times 7 is 5.25. 5.25, what is the unit of measurement? The unit of measurement is meters. Use your model to find the distance required. So distance is unknown. We're probably seeing similarities. Again, we're seeing that this is a very common progression for this type of problem. Distance required for the size to be 10 meters. So that means I do 10 equals 0.75 times D. Seeing it all written out, I see that I just need to divide both sides by 0.75. So 10 divided by 0.75 is 13.3 repeating. So sticking to my 3 significant figure rule of thumb, I'm going to do 13.3 meters. And we are done with problem number 3. Last problem for your homework today. The volume of a regular dodecahedron varies directly with the cube of the length of an edge. Oh, hey, this was your exit ticket. That's my bad. Okay. Well, we'll go ahead and explain it again. So varies directly with the cube of the length. That means that y equals kx cubed. And y is really your volume. And x is really the length of the edge, which is a. So we're going to say that that is going to be v, and that is going to be a. So I do v equals k times a cubed. 958 equals k times 5 cubed. K is 125. K is being multiplied by 125. So 958 divided by 125 is 7.664. All it says is to find the constant of variation. It does not say to write the model, but I know I'm going to be using the model later, so I might just at this point right now just write it out to the side as a point of reference for these later problems. I know it's always going to refer back to that. So I'm going to find the volume when the edge is 8. So volume equals 7.664 times 8 cubed. 7.664 times 8 cubed is 3,923.97. Three significant figures, 3920, 3,920 centimeters cubed. Last piece. We're going to find the edge length when the volume is 100. So we plug in 100 for V equals 7.664 times A cubed. I divide both sides by 7.664. And then I take the cube root of that number, and I get that A to three significant figures is 2.35. It's meters cubed here, which means that this is going to be meters. And that is your homework.